Okay, cool. So today we're going to talk about stealing web cookies. So I like this. This is kind of a fun talk. So the first question is, what's a cookie? Right? Anybody know?
Seen that before. Heard of it.
Yeah. Okay. All right. Well, let's ask you a different question. What's the oldest web page you can remember? When was the first time you got on the internet? Do you remember? Long time ago. Yeah. Do you guys remember before the internet? Maybe I'm getting too old. I remember there was no internet for a while. Okay. Yeah, okay. So for me, the oldest internet was kind of like early, like AOL stuff, like Netscape, Navigator. The web pages were really boring, right? They were basically like a bunch of text and some pictures, and that's about it. And you would go from one web page to the next, and you basically just read things. They weren't interactive like today we have Facebook and Gmail and all those things that, it's all kind of just one web page, but it's like really interactive. You can do all sorts of stuff there. You don't have to leave, right? You just stay on one web page. Um, so the cookie is kind of what enabled that. In fact, Netscape, they were trying to build a website kind of like Amazon, an e-commerce website, and they wanted to create a shopping cart. In fact, they have the patent on the digital shopping cart, right? It seems like a pretty basic idea, but they patented it. So what they wanted to do was like you could go to like a product page, and if you liked it, you could put it in the shopping cart, and then go to another page, and if you like it, put it in the shopping cart. And the shopping cart should remember what you put in it from each page before. But the old internet was stateless. If you went to a new web page, you forgot everything about the last page. So somehow you have to remember something from page to page, and that's what the cookie is. So the cookie, basically just a text file. It stores some information that the next web page can use. Yep. So we can use it for things like building a shopping cart, but we use it for something really important now. And now we use it for authentication. So when you log into a web page, we give you a cookie, and that's how later when you. So okay, let's go through a flow. Let's say you go to Facebook, right? And you never logged into Facebook, so the first thing you do is you enter your username and password, and you get logged in, and Facebook generates just a random number, and they give you a cookie with that random number in it, right? And from then on out, only you and Facebook know that random number. Nobody else should know that random number, right? So in the future, after you log in, you maybe go to your homepage, you see what's going on with your friends, maybe you want to post an update to your wall, and each one of those requests, we don't have to send the username and password again. We've already logged in, right? So what we do is instead of sending username and password, we send that cookie with that secret number, right? And the web server says, oh, you want to post something to your wall, and you sent me this cookie value, and oh, I remember that. That's Jill. I gave Jill this random number, a week ago, and only Jill should know that number, so it has to be Jill, right? So your cookie is now your identity. So everything is just based on that secret number. So if somebody else knew that secret number, they are you. It's based on that secrecy. So a username and password gets you a cookie. You get cookies for all sorts of things, but you can get an authentication cookie when you log in. And if I know that value of the cookie, I am you, right? There's no more username and password. And sometimes these cookies last for a really, really long time. Like Facebook could last for a month maybe. So if I get the cookie, that's really valuable. So let's do that. So I'm logged into Facebook, and let's see what cookies Facebook gave us. So they're tracking a lot of information about us. They want to know things. So some things are pretty simple, right? Like they're saying that we are in the US and it's English, so probably I should send them the English version of Facebook and not the French or Chinese or Korean or whatever, right? That's pretty important. We should track that. We should remember what language the user speaks, right? Here's the one where after we logged in, Facebook gave us this secret random number, right? So they gave us a value that's your user value, and your user value is the secret random number. So remember, if I have this secret random number, I am you, right? So let's go ahead and let's just copy all of this to the clipboard. It's just text data. Let's just put it in the clipboard. I'm going to go to another computer here. So this is a virtual machine. I'm not logged in on this computer. So let's go ahead and send a request to Facebook with that secret value, right? So I'm gonna go ahead and import that. Just drop all the cookie values in there. Okay, so we can see the C user, the same ID here. So now if I reload Facebook, I'm logged in, right? I don't need a username and password. I just need that secret value. Let's pretend that you guys are all the attackers and I'm the victim, and I just logged into Facebook on my computer, right? So every request that I'm going to send from here on out, each page I browse in Facebook, I have to send that cookie value again, right? So that cookie value has to go from my computer somehow out through the internet all the way to Facebook. Facebook's going to get it and then send me the response, right? And your goal is to get the cookie. So you guys have any ideas how we can get that? Yeah.
Well, I guess.
Yeah, so all we have to do is you have to be somewhere between me and Facebook, right? And so let's see, how am I connected to the internet right now? Well, right now I'm on the wireless, but let's think about, maybe I'm plugged in through the Ethernet, right? So basically we're doing wiretapping, right? We want to listen to all the traffic that my computer is sending because somewhere in that traffic is the cookie, right? And if you can get the cookie out, that's all you need. How did Ethernet networks used to work? So we used to, if my computer wanted to send a message from one computer to another, I'm connected to, let's say, a hub on the network. Basically, what will happen is that message will go to the hub, and the hub says, I don't know who this is, so I'm just going to echo the message to all the other computers on the network. And if the message wasn't intended for you, you just ignore it. But if you're a bad guy, basically what you do is stop ignoring the messages, right? You start looking at all the messages because somewhere in there can be some cookie values, right? So that was kind of a bad design from a security standpoint, and also it's kind of a bad design because it generates a lot of extra traffic on the network, right? So now what we use is something like a switch. So we've been using switches for like a long time now. So there's one up on the wall even there. And what the switch will do is instead of echoing it to everybody, it'll just send it to the right person. Right? Now we can still try to like trick the switch into giving us somebody else's stuff by like pretending to be that person, but it takes some extra work. Now, if we think about the wireless, there's no direct route to the person, right? So we have to kind of broadcast our message to the world on the radio waves, and anybody that's kind of sitting around could listen to all the radio signals and then see all the traffic, right? So if I go to the library and I get on the Iowa State network, the IA State, all caps, that's open, unencrypted internet. So I can see all the traffic at the library, everybody's traffic on the library, right? Now, that's not great, so we should probably be using encrypted Wi-Fi, right? So that even if I'm looking at the traffic, I can't understand it. So we have an encrypted one. I don't know why Iowa State still has the unencrypted one, but we should all start using the EDU Roam one. Basically, you enter your net ID and your password, and it encrypts all of your wireless traffic. So now I can't understand what your wireless traffic is, right? So that's one way. The other thing we can do is, regardless of how we're going to send the message, we could encrypt it from the browser, right? So we can let the browser encrypt it before it even goes out to the network. And so this is what the HTTPS protocol is, which is the little lock icon in your web browser, or SSL, any of those things. They're all the same thing. So about, 2 years ago, we could do something like go to the library, and Facebook would use HTTP, the unencrypted version by default. Everyone's on the IA State network by default because EDU Roam didn't even exist. And we could just get all the cookies to Facebook, and then we get a whole list of everybody's profiles, right? All logged in, right? So that was pretty easy to do, right? And then people started encrypting their wireless, good, right? And also Facebook started, they don't allow HTTP only anymore. You can only do HTTPS. So now we can encrypt everything so we can't see it. There's some other tricks we can do. So basically, if we can trick Facebook into sending some malicious code back to the user, we can get them to run that code in their browser. And then that code could just take the cookie value and send it to the attacker. Right? So all that kind of fancy dynamic interaction with the web pages now, that's all client-side code, things like JavaScript. And that's all code. But if we can trick the server into sending something that looks like code back to the user, there's lots of ways to do this. then we can get the cookie. So we can protect that by using the HTTP only flag, which basically says that client-side code should never be able to touch this cookie. And then the last thing is our web browser has to remember all those cookies, right? Because if you log in today and then you want to go to Facebook tomorrow, you don't have to log in again because you've already logged in once. So we should just remember the cookie that we had, probably save it in some file somewhere, and then load it and send that cookie, right? So what we can do is just run some code on the victim's computer, go into Chrome or Firefox or whatever, find the cookie, and then send that to the attacker, right? Now, the browsers have started getting smart in the last year, and they started encrypting the cookies also on the computer. But we're kind of lazy people, and we don't want to have to enter a password every time, so they just encrypt it with the same password every time. So Chrome will encrypt your cookies with the password peanuts. And so I can just decrypt your cookies using that same password, and everything works again. So I'm going to show you that code. So this code basically goes into Chrome, searches for any cookies for Facebook, and then prints them. So I'll go ahead and run this. On the Mac, there's a nice feature that Apple says, oh, you're trying to use the keychain to decrypt a cookie? Well, I'm going to ask the user if that's okay. Sorry, I lose my voice. I'm going to ask the user if that's okay. So I'll be a dumb user and I'll say, sure, you can do that, right? And so we can get our cookies here. Oh, low battery. But, good job, Apple, for, asking the user if that's okay. But bad job, Apple, because they have another feature which basically lets me ask any application to ask a user for something on my behalf. So here's just a little, it's not even code, it's just something that, it's a feature, really, of Apple. That allows me to ask Chrome to ask the user for their password, right? So it just pops up a little dialog that says, Chrome needs you to enter your password to apply an important security update. So I'll go ahead and run that. And we get our little pop-up. Let's just enter some password. And that's the password we entered there, right? So this is something that comes with Apple. I don't really know why that's a feature. But so what I could do is I could basically do this instead of the other pop-up, right? And I could trick you into doing it and make it look like a legitimate thing. Yeah, thanks for coming.
Thank you.